Before start the experiment, it is necessary to ensure that gloves are worn before starting the experiment. The water sample from Taman Tasik Section 2. To conduct this experiment, we prepared seed beaker and filled up the sample water of 1000 ml into each beaker. Next, all the beaker were arranged into jar test apparatus.
Ferric chloride was put into another beaker before being put into the water sample beaker. By using a syringe, add different quantities of dosage of coagulant, which is ferric chloride, into each beaker.
The propeller need down into the beaker and make sure the propeller does not touch the surface of the beaker. Speed are set for 140 rpm as rapid mixing process and set timer for 3 minutes. After 3 minutes, the propeller will stop and we can see the flock is forming. Next, we need to reduce the speed to 70 rpm as slow mixing at 5 minutes. After 5 minutes, the propeller will stop again and set 15 minutes to be flock settled down into the beaker.
For pH test, first, the water sample was poured into the clean beaker. Then, the probe was rinsed with distilled water. The probe was inserted into the water sample, ensuring the tip is fully submerged. Then, the pH meter was switched on and was set into pH. Then, the pH value was recorded and the step was repeated for all water sample. The pH test was performed to observe the effect of coagulant addition on water acidity or alkalinity.
First of all, we need to rinse all each turbidity bottle with distilled water, then add 10 ml of water sample containing the respectively coagulant dosage into the turbidity bottle. The turbidity bottles was wiped with tissue before insert into turbidity meter. Using the turbidity meter, we need to click range, auto range, and then read. Wait until the value reading was stable. Then, the process repeat for 6 different turbidity bottles.
For my part, I will explain the color measurement procedure after the jar test. After the flocks had settled, a clear water sample from one beaker was carefully collected into a clean sample cell. The outside of the sample cell was wiped with a tissue to remove any fingerprints or water droplet, as this could affect the reading. Next, the sample cell was inserted into the spectrophotometer. The instrument was set to the color test at 465 nm and the color value was measured in platinum cobalt units. The same procedure was repeated for all the remaining beakers so that the color value of each coagulant dosage could be compared.
For the result and analysis, from our result, we observe that turbidity decreased continuously as the aluminum sulfate dosage increased from 0 ml to 15 ml. The turbidity was reduced from 22.4 NTU to 6.22 NTU, which is about a 72% reduction. This happened because aluminum sulfate acts as a coagulant. It neutralizes the electrical charge of suspended particles, allowing them to combine into larger flocks that settle more easily. Therefore, increasing the aluminum dosage improved the coagulation and sedimentation process. For color, the readings fluctuated throughout the experiment. This fluctuation may have been caused by uneven mixing, incomplete flock formation, or small experimental errors during testing. However, the lowest color value was achieved at 15 ml, indicating that the highest aluminum dosage was the most effective in removing colored substance from the water. The pH showed a gradual decrease from 7.33 to 6.12 as the aluminum sulfate dosage increased. This is expected because aluminum sulfate releases hydrogen ion when it reacts with water, making the water slightly more acidic. Even though the pH decreased, it remained within a suitable range for the coagulation process. Overall, 15 ml of aluminum sulfate produced the best treatment performance because it resulted in the lowest turbidity and color value while maintaining an acceptable pH. This shows that aluminum sulfate is an effective coagulant for improving raw water quality and can help enhance the efficiency of water treatment before further purification processes.
This experiment highlights the importance of raw water quality assessment before entering a water treatment plant. The reduction of turbidity and color improves treatment efficiency and water quality. This study also supports SDG 6 by promoting clean water and sanitation and SDG 14 by reducing water pollution. In conclusion, the jar test successfully identified the optimum coagulant dosage and demonstrated the importance of treatment optimization for a safe and sustainable water supply.